Okay, here we go again, and I have a million slides, so I'm going to try to be coherent, but a little quick, move through things a little more quickly. While I'm talking, if you find yourself spacing out, take a minute, take a piece of paper that's in your folder, and think about one or two areas of your life where you feel like maybe you could make a small improvement. And so that by the time you leave here, you'll have a couple little goals, okay? I always find that useful, and then I ignore them sometimes. But eventually I get around to them. So I think self-improvement is a continuous operation. So I want to talk about nutritional genomics. And when I was, so here's our objective. So when you were in high school biology or maybe in college, you learned about genetics, and we learned about Mendel, and we learned about that your genes are set in stone, and that you get a gene and that's who you are, okay? But then we know that that's not really true, because we know that since the turn of the 20th century, that as people started getting more access to food, we can say what we want about the Industrial Revolution, but people had more abundant food, and they had more calories every day. People started getting taller, right? We know that if you have a child who has Down syndrome, and you nurture that child, and you give that child really good nutrition, that child can be mainstreamed in school. And children with Down syndrome used to not be mainstreamed in school, right? So we know that we can change our genetic predisposition by doing different things. Now, we might not be able to change our hair color or our eye color, or, there's certain things that are semi-inherited, but what we know now from this field is that every single second, your genes are getting turned on and off. They're getting told to express themselves or not express themselves. And so I want to talk with you a little bit about some of the research on that and try to show you kind of some of this revolution. This is brand new stuff. And I think the first place we're going to start seeing it, and we are seeing it, is in prescribing of drugs. And so if anybody's taking warfarin, for example, we know that there's certain genes that warfarin is going to be terrible for you, or women who are taking tamoxifen post-breast cancer, if they have a certain genetics, it's not going to be a good drug for them. And the drug companies are pouring a lot of money into trying to figure this all out, because these mechanisms are very well known. And in the future, a doctor won't give you a drug without looking at your genetics, because they get metabolized through different pathways. And if you have a blocked pathway, it might not be a good drug for you, or you might be able to take it in really tiny amounts because it's going to stay in your system longer. If you've got a system that's wide open, the drug might not be good for you because you're going to metabolize it so fast, or you might need to take really big doses of it. And so all of this is going to be personalized, and the government is putting a lot of money into this. So we're going to kind of take an overview of just genetics, and I call it 01. It's not even a 101. It's just really basic. Then talk about some of the research in nutritional genomics. Then talk about specifically a couple slides on genomics and diabetes. And then I think I'm going to fly through the testing stuff and not really go into that, and then do some practical takeaways. So the interesting thing is that every cell in my body and your body has the same genes as every other cell in your body. So why is one a skin cell, and one's a lung cell, and one's a toenail? They're really different, right? Because most of the genes in every cell get silenced. They get turned off. And only the properties that particular cell needs to have get turned on. And so this is happening. So like if we started growing toenails on our cheek, that would be really weird, right? But our body knows not to do that, and our body can know all these different things, but we can give it different messages by what we do. Our genetic information in every cell is stable, but which ones get turned on and off are not stable. They get turned on, they get turned off, and when we have a gene that gets turned on, what happens is it gets turned on so that we can make a protein. Genes are about making proteins. And proteins in our body are muscles and hormones like insulin and thyroxine, which is our thyroid hormone. And there are enzymes that are catalysts that make pretty much every single process in your body work. So, the ability to make proteins is really important. The ability to turn off making that protein when you got enough of it is also important. So we all, maybe you remember like the I Love Lucy episode where she's on the conveyor belt and those pies just start coming faster and faster and faster. So like we want to have a turn off button so that we don't keep making pies. The pies aren't flying through the room. And when you think about some kind of a health condition, what's one where the body doesn't know how to turn off making things? Cancer, okay? So in cancer, some of this research started. It's like, well, how can we turn these things off? So, and we're all born with, like your mom or dad had a really annoying habit, now you have that really annoying habit, or they had a certain propensity to a certain health condition, and now you have that health condition. We're also born with genetic predispositions, and we're also born with what's almost like paper clips on certain genes. It's like we put a little sticky note on it, and we say, oh yeah, this is what's weird about me, okay? And we all have these little genomic markers, and those markers can get taken on and off like a sticky note or like a paper clip. And so that's kind of the exciting thing, is that some of those weird things that we think we inherited or that we've developed, sometimes we can turn off by taking off these notes. So these are identical twins, and when we start out, you can see that the little toddlers, they look just alike, really, except the color of their pacifiers. But you can see that the older twins, that life happens. Their environment was different. Even though they're dressed the same, the one on the left looks a lot younger than the one on the right. She looks like she's in much better health, I think, anyway. But they look different from each other. And that's because they've gone through different life experiences. They've eaten different foods. Maybe one has been married 4 times and never did that really well, and the other one's had a really happy marriage. Maybe they just have different attitudes, because you know how people and families take different roles. And maybe one was a pessimist and one was the optimist. You never really know. So what we can see from studies, from twin studies, so I want you to look at the black boxes that have kind of the bright stuff in them, because they're the easiest ones to see. So the top row is of 3-year-old twins. And you can see they're not exactly the same, but they're pretty darn close, the colors. But then when you look at 50-year-old twins, their black boxes, they're really different, because they've had a different environment that they've grown up in. Even though they're genetically the same, they're not genomically the same. And different genes get turned on and different genes get turned off based on, if you lived with somebody who was really hostile towards you, if you were abused, if you were a dad and you worked 60 hours a week to support your family, and your identical twin kind of walked into something really good and was, retired at the age of 50, you're going to have different genes. Or maybe you worked in a factory and were exposed to certain chemicals and your twin wasn't. All these things have an effect on your genes. So every cell has every gene, about 25,000. And then we each have somewhere between 3 and 4 million what we call SNPs. These are single nucleotide polymorphisms. And the best way that I can describe them is that in this room we have people with gray hair, we have people with black hair, we have people with blonde hair, we have people with brown hair, and I'm not seeing any redheads, so that's good. So we got 4, up, 5. Well, there was only 4. So in genes, there's only 4, okay? There's 4 types, and for different genes, there's 4 different types. And there's one we call the wild type, which is usually the most healthy, and you usually see that in the most people. And then there are others that are variations of that, like just having different hair or eye or skin color that are just slightly different. And we have millions of these differences, but there's only so far maybe 100 that we know that really make a big difference in how you function. And that's where the research is getting poured into, is what are the ones that are really different, for example, in somebody who has diabetes versus somebody who doesn't, or somebody who has type 1 diabetes versus somebody who has type 2 diabetes. And then if we know what these are, then can we figure out like what might be driving the bad ones to get turned on and driving the good ones to get turned off, and what can we do to modulate that? And that's pretty exciting, okay? So again, you know, these, whether they're turned on and off is really determined by our environment. And these are women bathing in the Ganges River, which I think none of us would want to do. But in India, if you are religious, bathing in the Ganges River would be a holy event, and your attitude would be really different, which would turn on different genes than if one of us was asked to take a bath in the Ganges River, which we would say, it's polluted, I'm not getting in that, and we would have a bad attitude, and we would turn on different genes. So genetics 101, okay? So we've got the cell, and in the nucleus of the cell, we've got the genes, and we have 23 pairs of genes that are matched, and on each one of those they have different sets of codes for different events, and that these pairs are connected in these helixes. The genes are connected in helixes, and each gene is connected in a helix, not the pair, and those are held together by nucleotides, which are by 4 different nucleotides, which is why there's 4 different types, and I'll show you that more later. So to go a little bit more deeply, we have the cell, and then in the cell we've got the chromosomes, they're in the nucleus, and then they're wrapped up really tightly into something we call chromatin, and if you could unwind the genes that are in one of your cells, it would unwind to be about 6 feet or more. So it's really important that they're wound really tightly, because when they're open, then they're transcribing messages. I like to think of it like my filing cabinet. If I want to get something out of my filing cabinet, or even out of a file in my computer, but my filing cabinet is a much better example, is that I open a drawer, I pull out the file, I take out the right piece of paper. If I'm in the right mood, I use it, I put it back in the filing drawer, and I put it away, and I close the drawer. But sometimes, do you always put your files all the way back where they go every time? No, sometimes we leave things out and open, which means in gene talk, it keeps transcribing. It keeps making more and more of that protein. So we want them to be able to unwind, and then we want them to be able to wind up. And again, just kind of another picture of the same thing, because I wanted to show you these. The histones, the nucleosomes, the histones, they're like beads on a string. They're always described like beads on a string. And they make these kind of, you can see the small circle up there, and then it's blown up. And they make kind of like this jewelry where you've got these little clumps of these nucleotides. And when the string opens wide, we transcribe, and when it closes, these beads close back up, and then we stop making that protein. So you're making insulin because you're insulin resistant. You keep making more and more because your body tells you you keep needing more insulin. Or maybe you're not making insulin anymore. And most of this happens on the cytosine component. And I just kind of want to show you this act of how it opens and closes. And okay, so here's gene expression. And you can see these are those little histone bodies, and they're clumped together. And then what's going to happen is there's a methyl group. And the methyl group, which is NH3, a molecule goes and sits on that methyl group, and it gives the message. There's a histone deacetylator, and it gives the message to close the whole thing and end the process. So most methylation closes the process. It's like closing that tab, and we use methylation for hundreds and hundreds of things in our body. And so when these histone bodies are open, we're transcribing, and then we close them with methylation and deacetylation. So let's start talking about some of the research in nutrigenomics. We're starting to find that the foods that we eat turn on and turn off different genes in our body, which is pretty interesting. And so here's a book that was written by Greg Graham and some other people that I really love, because it just kind of takes you through the story of nutritional genomics by taking you through all the research, but telling it like it's a big story. And I like that. And so what we know is that in the world of science, there's all these different omics. There's genomics, then there's epigenomics, which is, what we're bathing our environment in. There's transcriptomics, which is how we transcribe these proteins. There's proteomics, which is about the proteins themselves. And metabolomics is how our metabolism works, which I just told you earlier is mostly your microbiome doing that. And we know that diet really makes all of these things run. And so again, when we're eating real food and not new to nature food, like most American food is new to nature, it's made in ways that we never saw before. It affects who we are. So Dean Ornish, some of you probably know of him from his work in cardiovascular disease. He took people and put them on the Ornish program, which is basically a low-fat, mostly vegetarian, high vegetable diet. He had them do stress management an hour a day, which was breathing exercises and meditation, walking 6 days a week for half an hour, and 1 hour of a support group meeting, and then a nutritional supplement with a little bit of protein or tofu, and then a little bit of fish oil and some antioxidants. They did this for 90 days in men who had slow-growing prostate cancer. And what they discovered was that in this process, and this is a heat map, on the left side is before and after is the post, and you can see that it looks really different. And what they were able to do was they were able to upregulate 48 genes that were cancer protective and turn down 453 genes that promoted cancer through diet and lifestyle. I was floored when I first saw this. Wow, this is amazing. This is the power of exercise and meditation and good food. You can change your genes. So then I heard about Randy Girdle and Ellen Dolinoy and Michael Skinner, and they started taking agouti mice. Agouti mice are bred for doing research on obesity and diabetes. And the mice that you see right there, they are a litter. These are identical twins. And you can see that they don't look identical. And what they discovered was, well, if the pregnant mice isn't methylating right, she's not closing up those strands of beads, she can't do that, then she gets more of these obese diabetic mice. But if they start giving them B vitamins, folate, B6, B12, and betaine, if they gave them methylation nutrients, that they got more of the brown, skinny, non-diabetic mice in every single litter. Give the pregnant mom B vitamins, you get more lean mice. So then they said, well, what if, and we know that bisphenol A helps promote diabetes, so what if we give those pregnant moms bisphenol A, but we still give them these vitamins? They found that they still had more brown, skinny rats and mice that didn't have diabetes. And so this was the first time we saw, oh, you can turn on and off methylation, and you can even modulate environmental chemicals by making sure that these mice have the right nutrients. So how does that translate into, so I'll show you how that translates into something. And then we also have some research showing that these genetic methyl tags that we all have get put on and that they cross generations. And so there were studies that were done in Sweden they looked at harvest records, and in men, they looked at men who had great abundance of harvest when they were in puberty. Lots and lots of crops. It was a really good year, and their grandsons had way more diabetes, 4 times the risk of diabetes. Now, the other half of that story is that this was a fishing village, and when they had poorer crops, they ate more fish. So it wasn't maybe it was the type of food that the grandfathers were eating. They also found that women who were babies and toddlers, where they had hardly any food, food was scarce, that there was increased mortality in their granddaughters. And so far, the research has kind of gone from grandmother to granddaughter and grandfather to grandson. But we're starting to get this body of this kind of, how do we carry these things through? And what effect does abundance or leanness of food have in our culture? And I look at it, I'm a baby boomer. There's a lot of baby boomers in this room. And we were the first kids to have frozen pizza, tater tots, Geno's pizzas, frozen orange juice, okay? And then our kids started getting microwave food. And then more recently, genetically engineered food in the 90s. And so I wonder, what kind of epigenetic tags we've been putting on, we got on ours, but then our kids, what have they put on theirs with all the microwave foods? And then the next crop of kids, pretty soon they're going to start having kids. And what we're seeing is that environmental changes are causing 12 to 15% of our kids to have ADD and ADHD, attention deficit. We've got over 2% of our children who are diagnosed with autism, and we also have over 10% of our kids getting diagnosed with depression. So you look and you go, well, what kind of epigenetic tags are there? And this is my great-grandmother, my aunt, and my grandmother. I like to use my own pictures if I can. So there's some specific SNPs that are in the news, and I wanted to just show you just a couple of these. So one of them that's in the news a lot these days is the ApoE4 gene. And why it's important is it's really associated with cardiovascular disease and Alzheimer's. And 25% of us have this gene. Because remember I said there's only 4 kinds, right? But you get one from your mom and one from your dad. So if you get 2 of these genes, 2 copies of this gene, one from your mom and one for your dad, you have a 46% increased risk of cardiovascular disease. But when you look at Alzheimer's, if you don't have any, you have like a 9% lifetime risk of developing Alzheimer's. If you've got one, an increased risk of a third, 30% increased risk. 2 copies, 50 to 90% increased risk. So you would want to be able to turn this gene off if you had it, wouldn't you? You'd want to say, hey, shut up, buddy, So what we know is that a high saturated fatty diet increases the risk. But we know that Mediterranean diet, which is rich in all those foods I was telling you about before, it silences this gene. So if you knew that you had a double allele or even a single allele of this gene, wouldn't you want to eat more vegetables and eat a more Mediterranean diet? And we have a lot of really good diets out there. I gotta say that the research on the Mediterranean diet makes the most sense to me. It works with breast cancer, cardiovascular disease, diabetes, you name it, it works, okay? So eat your vegetables and olive oil and nuts and seeds and you'll feel better. We also have another gene called the MTHFR set of genes, and there's one gene here called the 677C or T gene. And when people have the CC, meaning C from both of their parents, they're really good at metabolizing folate from green leafy vegetables. And folate is so important for embryonic development. It's important for prevention of cancer. It's really important for energy. And neurological health, really important nutrient. When we have about half of us have that type, and about half of us have impaired metabolism. So I'll tell you a personal story. When I was in my early 30s, I went to a conference, and I heard about this researcher named Butterworth, and he had been giving women who had cervical dysplasia that was shown up on pap smears, he was giving them huge amounts of folic acid every day, 10 milligrams. That is about 25 times the recommended dietary allowance, okay? So I started thinking, and said, well, I'm not on the pill anymore, but when I was on the pill, I started having abnormal pap smears, and now I still have some abnormal pap smears once in a while. I'm going to start taking 10 milligrams of folic acid every day. So I started doing that, and I did that for maybe 6 months, and I noticed that I had a pap smear. It was totally normal. I never had an abnormal one after that. But after doing that, I also noticed that the breast tenderness that I had premenstrually disappeared, and I noticed that my hangnails, that the skin tabs on my fingers were gone when I was doing that. It's like, I have a much higher need for this than an average person. Now I know this about myself. So when I finally had my genetics tested, what I discovered was what I already knew. I wasn't very good at metabolizing folic acid from food. So sometimes it just tells you what you already know, but I'm kind of weird nerd that way. So anyway, so if you have a CT, one of each copy, you metabolize it about 40 to 50% less effectively, and that's about 40% of the population. And if you have the TT gene, you're really bad at using folic acid. And I'm not that bad. I'm in this green category. We now know that there's at least 15 different methylation SNPs that determine a lot of, it's the balance. It's kind of like having an orchestra. There's not one that's going to make the difference. And so I just wanted to show you this kind of quickly. So here's the MTHFR gene, and there's the folate cycle. And it also drives something called the methionine cycle, which leads you to SAMe. And SAMe has been used for people who have arthritis and depression. And then the SAMe leads to homocysteine. Any of you have high homocysteine levels? And then the homocysteine is dependent on vitamin B6 to make glutathione, which helps us excrete metals and chemicals out of our body. So when I was a kid, I had this little game with gears, and I could put pegs in them and make them move around, and I really liked that. And this is the same way. If we go the other direction, that MTHFR, which would be like the little handle that's turning everything, is it takes us into our neurotransmitters. So when this isn't working well, we get people who are moody. When it's working too well, sometimes we get people who are really anxious and overdriven type A's. And here's a fancier chart, and they get fancier and fancier. But there are nutrients all the way in here. So up there, there's riboflavin, and down here, there's vitamin B6 and magnesium. And so when we don't have the right nutrients, and most people with diabetes don't have enough magnesium or B vitamins, okay? So when we don't have the right nutrients, these don't work. And methyl impairment, you see it in people who have repeated miscarriages. So by the time I'd actually done my genetics, I'd already had a couple miscarriages, you know. So again, folic acid, neural tube defects, strokes, cardiovascular disease, cancer, anything neurological, diabetes, type 1 and type 2 diabetes. You know, so think methylation defects if you're thinking diabetes. So think B vitamins, think even a good multivitamin can help a lot. And these are just some of the things, but I wanted to show you that, you know, prenatal exposures, diet, and physical activity, and that there's all these different methylation pathways and all these different genes that are involved that are getting studied. And if you want these slides, just let me know and I'll give you bigger ones. So we always think of this gene specifically as being a folic acid gene, but in this study they gave people a multivitamin, like a Centrum Silver level of riboflavin, which is vitamin B2, and it lowered their blood pressure. Because these are symphonies, everything works together in concert, and so you can't take a single snip and say, oh my gosh. I've had people come to see me, I'm not in practice anymore, but when I was, people would say, oh my gosh, I'm MTHFR677TT. Is this a death sentence and I'm going to get all these terrible diseases? And it's like, no, you just need more folate than other people. You know, these things are possibilities. They're not death sentences. And that's what's so exciting, is because we can understand how to modulate them. Eat more green leafy vegetables. Like, I crave greens. I crave certain green, high folate rich foods. And if I don't have them, my body needs them. So here's some of those foods, nutritional yeast and liver and milk and whole grains and nuts and seeds and dairy products and celiac disease. If people have celiac, we know that they have certain genes. So if you've got somebody in your family and they have celiac disease and you want to know, could I have celiac disease? You can have your genes tested, and if you don't have those genes, then you're never going to probably get celiac, because it's like 98%. However, about 40% of us have those genes. So again, only 1% of the population develops celiac disease, so they're doing something different. Vitamin D, we can see people who are out in the sun all the time and their vitamin D levels are really low. And we now know that there's at least 5 or 6 different vitamin D receptors. And if these receptors are less effective, then you're going to need more vitamin D. A friend of mine has osteoporosis, and she was taking 5,000 units of vitamin D every day, and her vitamin D levels weren't going up at all, and her bone density wasn't improving. So she found out that she had these really sluggish vitamin D receptors, and she started taking, I think, 10 or 15,000 units a day, and all of a sudden her bone density started getting better, and her levels went up. We also have genes that help regulate inflammation, so some of us get more inflamed easily than other people. And then nutritional genomics and diabetes. So this is a study called the Fungenut study. Again, they did this in, I think, Norway. And they took people who had metabolic syndrome, and they divided them into 2 groups. In one group, they gave most of their grains in rye and pasta, and the other group they gave wheat, oat, and potatoes. And what they found was that when they did those gene mappings, that in the rye pasta group, and people who had rye, that they downregulated 71 genes that had to do with diabetes, cholesterol, triglycerides, and heart disease, and blood pressure. And in the wheat oat group, they had 62 genes that made them worse. So my question is, well, what if you did this study in the same study, but you did this study in Ireland, where people have been eating oats and potatoes for millennia? Would we get different results? And we might, because in Finland they eat a lot of rye. They eat a lot of rye. People in Ireland don't eat a lot of rye. So there's a lot of questions that we don't have answered. I'm not telling you eat rye bread instead of oats. And then we have the Mediterranean diet, and the Mediterranean diet has shown to be associated with benefits to so many different genes. Turns on the protective genes, turns off the genes that make us sick. So with diabetes, genetics accounts for about 50% of type 1 diabetes in identical twins and only 10% of type 2 diabetes in identical twins. So there's definitely a genetic component, but it's not an enormous genetic component, especially in type 2 diabetes. And we know that in type 1 diabetes, a lot of times, somebody's going along normally and they have the flu or some kind of virus, and all of a sudden the next thing they know, they have type 1 diabetes, because we have a lot of infectious triggers of type 1 diabetes. So there are over 40 different known SNPs to affect type 1 diabetes and over 65 for type 2 diabetes. And if I give you this lecture next year, my guess is those are going to double. Okay, we are at the tip of the iceberg about what we know. So it's not like Down syndrome where you can go, aha, it's this one gene. It's this symphony of genes, and we know that it can be modulated. So again, chemicals, happiness, food, love, all these things can turn on the right genes. And I just started looking at some of the many genes that were involved, and I took them from a couple of papers and just started looking at some of the many genes and what they're regulating. And it's not to, you're taking a test on this and you're going to have to memorize it, but no, it's basically to start really thinking about, okay, this research is happening, and we do need to look at it. And on the par side, well, what helps? Polyunsaturated fats. Eat your nuts and seeds. Total fat intake. Carbohydrate intake. You need to have zinc and magnesium and beta carotene and vitamin E, magnesium, other vitamin D, whole grain intake, omega-3 fatty acids, green tea. All these things are found on the Mediterranean diet. So genomic testing, who may benefit from genomic testing? As I said before, we're going to find a lot that they're just for drugs. This is going to be the gold standard. They're going to look, they're going to see how well you metabolize different drugs, they're going to match you with drugs. Planning for pregnancy, this is an area that is so important to start looking at your genomics, especially in families that have kids that have allergies, or kids or families who have, I've met families where 4 kids have autism of different types. And I have 3 different colleagues, 2 of whom work with autism, and one works, she's an OBGYN. And what they do is they work with pregnant couples who want to plan for pregnancy, and they look at their environment, they look at their nutrition, they look at how well they're detoxifying, and they try to upregulate and optimize all of that before the couple gets pregnant. And then they start really watching these babies very carefully, and they start giving them nutrients and working with them. And so I have one friend, Dr. Liz Mumper, who's in Central Virginia in the mountains, and she's published this. She said of all the autistic families that she's worked with, she should have had 9 children with autism in her population in subsequent pregnancies in these families, because anyway, and so she had 0. When I saw her last year, she had now 1, but she had many more families. And so, the rates are much lower when you can do these things. And I've even seen interventions from Leslie Stone during pregnancy with a woman who had had 2 previous babies and wound up in the hospital almost dying with lung infection and blood pressure issues. And her doctor said, look, it's going to happen the 3rd time too. Don't get pregnant again. And she did, but she worked with Dr. Stone, and Dr. Stone did this type of modulation, and she flew through the pregnancy and the birth and didn't have to be hospitalized. So we're going to see a lot of this in early childhood, and this is where we're really setting somebody up for their whole life health. In children with special needs, I definitely want to know some of these things. And then if you have cancer or depression or heart disease or diabetes running through your family, you might want to do some testing. And then there's people like me. I'm just curious. I just want to optimize anything I can optimize. But I can tell you I've run so many genomic tests on myself that I'm completely confused. Yeah, so I have some advice about that. And so you don't look anything like the long-haired, skinny kid I married 25 years ago. I need a DNA sample to make sure it's still you. So that's another reason you might want to do this testing. So these tests are not functional, okay? It's not like testing your blood sugar to know what's going on. These are tests of possibilities that you can do things about. Oh, exercise upregulates this gene. Great, I'll get more exercise. Oh, eating too much sugar downregulates this gene. I'm going to stop doing that. These are telling you about things that you can do. And there's 3 different main types. There's like single SNPs, which can be useful, like I knew that methylation SNP, but not very useful, but could be really useful to just know a couple for celiac disease. There's standalone testing like Genova Labs has some, and I have a list of some of these. And then there's piggyback. So a lot of the testing I've done is I got a 23andMe, which I now find that a lot of the genes aren't validated in there. And so there are mistakes in that profile. And then I take those and I run them through other programs. So this is a Genova test where they do very specific genes for different things, and then they tell you very specifically what you can do. Here's a cardio gene test for that ApoE. It's part of that test. And Pathways Genomics, so here's a couple that I would recommend. Nutrigenomics, they have a health and wellness one and athletic performance, and they tell you actionable things that you can do. It's out of Toronto. And then Pathways Genomics, not only they give you a really good nutritional evaluation, but they also give you access to a nutritionist who walks you through and tells you exactly what this means. And then Great Plains Labs has one where they look at 1,000 SNPs and give you, again, actionable information. And then 23andMe, you can add a whole bunch of things to it. So you can take 23andMe and you can run it through all these different groups. And then we have next generation testing. So we have testing that's looking at how your metabolism works. We have Opus 23, which was put together by Peter Diadamo and his graduate students. He's the Eat Right for Your Type guy. And he has this is more a clinician's tool. So if you find a clinician who knows how to use this, they can really kind of help modulate what's going on with you. There are a lot of naturopaths who are using this. And then here's a whole bunch of testing companies. It's the wild, wild west out there, and I think it's going to settle down eventually, but we're just in this mushrooming mode. So did we get the cart before the chip before the horse? I think we did in a lot of ways. I think 90% of us don't need to do these tests, but when you have something and you feel like it's not right or you can't get to the bottom of it and your health isn't improving, even though you're doing all the right things, that's a really good time to do this testing. And there's a doubling, as I said, this is on hypertension. In just a few studies, they doubled the number of genes. We don't know what we're doing yet. And the practical takeaways. So food is information. You can eat the food on the left side of the slide, you can eat the food on the right side, and intuitively you know that they're going to make you feel differently, right? Okay? Now, you might really like eating the food on the left side because it gives you different health benefits, right? It gives you happiness sometimes, feels something. And then Mediterranean diet, one of the things I love about this is that at the bottom of the pyramid is regular physical activity, adequate rest, and conviviality, eating meals with other people. They show people at a table together, you know, eating a wide variety of food, eating traditional and local foods, using eco-friendly products, and then cooking. So I love that these are at the bottom of the pyramid. This is really the foundation of good health. There are many bioactive components, as we were talking about, all those polyphenols in the food. And then histone deacetylase, there we have drugs that are being developed that help close. Remember when I showed you that little video and the histone deacetylase came and sat on the methyl group and it just kind of went and closed up? So, but there are foods like garlic and quercetin that's found in apples and onions, and genistein that's found in soy, and coffee, and green tea, and cinnamon, which this group funded cinnamon research. And all of that, like using these polyphenol-rich foods, is something that helps us do this naturally. Okay, so that's prebiotics and herbs and spices. So one of the things I want to leave you with is, as above, so below. So the research that we have shows that when we eat real foods, it modulates our genes to be healthier and happier so that we're healthier and happier. We also have genomic research on yoga and meditation and prayer and eating cultured and fermented foods and listening to music and dancing and running, you know, and all of these things. We have research that demonstrates that we can turn on anti-inflammatory healthy genes by doing all the things that we know we should do. So my takeaway is to really start with the basics and make sure you're doing all of those before you start running to look for all the mysterious, crazy biochemical pathways. I have students who write me these long diatribes about a case, and they're missing the most important thing, like this person's only getting 3 to 4 hours of sleep a night. We have to always come back to the basics. So remember, your genes respond to what you bathe them in. And then if you want to get copies, like full-page copies of these slides, let me know. If you want that paper, let me know. And we have about like 12 minutes for questions. So anybody has a question? Thanks, everybody. So food is information. Sleep is information, right? Movement is information. Friends, learning. All this is information. This is good for your genes. Unless I overwhelmed you.
Can we thank Liz? You're wonderful. So listen, this was like a real college class, right? Did everybody learn something? Yes.
One person told me he learned about beer, and that was good.
So by the way, apparently some people had questions about whether this was being videotaped. Stephen Kaiser here is actually in the process. It'll be a few weeks before it's on the website, but rest assured you'll be able to watch and listen to all this again. So thank you very much. And you have the mic, portable. Any questions down here?
Oh, but while Philip's going up there, somebody was asking me about testing, and if I had diabetes or I had a chronic condition, there's one test that's run by Genova Diagnostics Lab that I would ask my doctor to do. It's might cost you about $170, but even if your insurance or Medicare doesn't cover the rest of it, that's all you would have to pay. It's not nothing, but it's something. But it's a really great nutritional test called a NutraEval, N-U-T-R-E-V-A-L. And the NutraEval looks at all of your vitamins and minerals. It looks at your ability to utilize protein, so it looks at amino acids, which is neurotransmitters and protein and everything else. It also looks at organic acids from urine and fatty acids. So it's the most complete kind of test that I know to really look at your nutritional status and some of your metabolism status, and can give your doctors a lot more information about what might be going on with you. Okay.
And also, I had a quick question, Liz. What's the best test for doing the methylation gene part of it?
So for methylation gene, the methylation panels can be done really through LabCorp or Quest or any of the big labs. They're doing them. The problem is often insurance won't cover them unless there's some kind of medical need. But diabetes should be well documented, and that code ought to get you paid for those.
And what about the 23andMe?
23andMe definitely looks at methylation, looks at a lot of methylation genes, and I ran my 23andMe through a $5 app called Genetic Genie, and it gave me my detox and my methylation status. And so you can do that. Pathways Genomics or the Great Plains test will also give you that.
So what was the question?
Okay. Hi, thank you very much.
Sure.
It was really educational. My question is, my daughter is forcing me to eat only raw veggies, not steamed.
Okay, so there
I
are.
mean, she's also like you, so.
Okay, so there are some enzymes and things that you can get in raw vegetables, but actually old studies were really interesting. There are nutrients, for example, like lycopene and vitamin A, the carotenoids that are in like carrots, that if you cook those foods, that you get a lot more out of them. And there are also a lot of people who really can't digest raw very well. I like to have a combination of raw and cooked. And so it's also a matter of what you like. And so I think a combination is really best. And I think also it also depends on the weather and the season. In the winter, we want more really well-cooked foods. In the summer, we want more raw, fresh foods. And so kind of working with the seasons and working with your own likes and dislikes. And you can listen to your daughter. I really like her, but you have to listen to your own body and what feels good in your body.
Okay. And if I want to send an email to you, how can I do that?
My email should be up here. So.
I put in the folder on the question if anybody wants that probiotic, the complete history of all probiotics. I put my email address and Liz's also, so I can send anybody that if they want it.
Thank you.
I think there's one question down here.
Even with cooking, if you use olive oil, that you get more than if you don't use olive oil.
Yeah, there are a lot of fat-soluble nutrients that are in the produce that get better utilized when we have a little bit of fat with them. You know, so.
By the way, there's something I just discovered and learned this past year. Avocado oil has a smoke temperature of 500 degrees. So I used to cook everything in coconut oil, but actually avocado oil you can use for cooking at any temperature.
It's good to have different oils, you know, walnut oil for salads and olive oil for certain things, and I use sunflower oil for cooking, or I use ghee for cooking, which is clarified butter, or I use, you know, it's good to have a variety. Variety and diversity make us better.
Piggybacking on the carrot question up there, or the raw vegetable question, is that carrot, we know carrots are good for us, but can we eat the carrot greens? I've never found a recipe or anything regarding carrot greens. Can you eat them raw, mix them in, use them as a spice? Are they too bitter? I don't know.
You know, they're a lot like parsley, but they're even more pungent than parsley. And so I, would maybe use them in cooking as a spice, but I wouldn't really eat a lot of them because they're just too intense. And when a food tastes that intensely, it's more of a drug than a food.
Oh, safe to eat relatively, though,
I don't know how much is safe to eat. Eleonora, do you have any good uses for carrot tops? No. She's shaking her head. No, don't. Give them to your bunnies.